Okay, so this video we're just going to go over some domain and range, what it is, how to find it, the difference between continuous and discrete graphs, and how to write the domain and range. You probably, hopefully, have heard of domain and range before, but in case you haven't, or if you need a review, um, this is where we're doing it. So just quick vocabulary. You got your notes with you. You want to get these down. We're going to start with the definitions of domain and range, the definitions of continuous and discrete. So the domain is the set of all possible x values or inputs. What is possible to put into the equation? It's not always everything. And that depends on the situation or the equation. We'll talk about that next, but really just focusing on what are they. So it's the all possible inputs, all possible x values. The range is the set of all possible y values, so the outputs. When we put those inputs in, what do we get out? That's the range. So a continuous graph can take on any value along an interval. It can be denoted using inequalities or interval notation. And discrete graphs, they're composed of distinct values and can be denoted using set notation. You want to get those in your notebooks. Make sure you have that down. When we go over examples of each, and maybe some of those words that don't make sense right now make sense then, you probably want to put a little example next to them. So let's get to a few examples, and then it should make a good amount of sense now. So domain and range. So we're talking all possible x values for the domain. So x is, the horizontal axis. So we're talking this function. It is a function. So this equation or graph goes from -5 to 5. Here's something we have to point out. An open circle means that the value does not exist. So at -5, it doesn't exist there at -5, but it does exist all the way up to -5. So like -4.999, yes. -5, no. Okay, so everything up to -5, but not including -5. So the domain is actually going to be from -5 to 5. So there's two ways we can write it. One is interval notation. Interval notation is written just like this. So we got -5 to 5, so the minimum and the maximum. And then we use brackets and parentheses to let you know if the endpoints are included or not. Are the endpoints included or not? So this 5, yes, included. We use a bracket for that, like this. This one is not. Since it's an open circle, we use a parentheses for that. So that's not included, and this one is included. So this means -5 to 5, but -5 is not included and 5 is. That's what this means. You can also write it with inequality notation. So -5 is less than x, which is less than or equal to 5. So just in the same way that these brackets tell you, brackets and parentheses tell you whether this is included or not, we use the less than or equal to denote whether or not those numbers are included. So -5 is less than x, and it's not included. So it's not less than or equal to, it's just less than. And x is less than or equal to 5. So you can see x is between -5 and 5. -5 is not included, and 5 is. Okay. So moving on to range. Range is the y values. So we're going to go, these are the vertical ones, the up and down. Okay, so yes, this point is not included, but this point is. So we do have from -2 all the way up to 2, which is included as well. So we can say interval notation -2 to 2, they're both included. Or you could say -2 less than or equal to y, which is less than or equal to 2. It is a function because it only has one output for each input. So let's do the domain and range here. Okay, well, I can't trace it because it kind of goes on for forever. That's what these arrows mean, right? That's going on for forever over there. That's going on for forever over there. So the domain is going to be all real numbers. So you can write that. You could write all real numbers. You can also say -infinity to infinity. Okay. When we're talking interval notation, those are never included. You can't include infinity. That doesn't make sense because infinity doesn't exist. Just conceptual. Just means we're going on for forever. So we always use parentheses when there's an infinity because you can't include infinity. So same thing if you were to write it like this, less than, you would never say less than or equal to because you can't be equal to infinity. X is less than infinity. Okay. You can see it's going to be the same thing with the range. It goes for forever that way and forever this way. So the range is going to be all real numbers as well. And again, you could write it like this, or you could literally state all real numbers if you wanted. And again, this is the function. This is a function. Okay, domain. For this one, you could see that we go from -4 all the way that way. So again, -infinity to 4. Sorry if I said -4, I meant 4. You never include -infinity. You never include any infinities. 4 is included though. And I have inequality notation right there. For the range, it looks like we're starting at 0 and it's going up for forever, right? There it goes, up for forever. So we're starting at 0 and it is included. We're going to infinity, which is never included. And it is a function, yep. Okay, this one is a little bit different. So these guys have been continuous so far, and that's what we mean by they can have any value along an interval. So from anywhere from 4 to 3, right, there's infinite points right here. 3.1, 3.2, 3.5, 3.6, 7, 8, 9, 2. So we can be any point along this. That's continuous. This guy's discrete, so it's a little different. They have distinct points, various distinct points. So it's this point, this point, this point, this point. Not the ones in between, though. Just specifically these points. We have to write that in set notation. So really, we want to say x equals, and then you open a brace like this. So that's a brace. And then you just kind of list them out. We got -3, -2, 1, 1, 2, and 5. Close the brace. Okay, that's set notation. X equals this set of numbers. The braces just mean here's a set, and then you put what numbers are in that set. Okay, so the same thing with the range. You could say that y equals open a brace, and then just list them. So notice I didn't put 1 twice. If 1's part of the range, then it's part of the range. That's fine. We just put it there once. Don't worry about it. But a discrete graph, you can just write it like this in set notation. We're going to go fast. The domain here, all real numbers, or -infinity to infinity. The range here, how far do we go up and down, up and down, up and down? Well, it's just right here. It's just 3. So you can say y equals 3, or you could say y is the set containing 3, whatever you want to say. That is a function as well. Domain here, -2 to 2, both included. Range here looks like 5, 1 to 5, both included. 1 to 5. Okay, last one. Again, we have to remember that these endpoints mean that it's not included. So don't let this zigzag kind of fool you. We're going to say how far does it go left? That's right here. That's the domain. And then how far does it go right? That's right here. So we've got from -4 to 3, but 3 is not included. 3 is not included. 4 is. For the range, we're starting as high as it goes and going as low as it goes. It looks like neither are included on the endpoints, but we're going from -5 to 5. Neither are included. And this is not a function because we got multiple outputs. So I also just realized that, just going real quickly, I accidentally put yes for this. This is not a function, excuse me. But there you go. There's domain and range. We got interval notation. We got inequality notation. And we have set notation if it's discrete.